Hello guys, welcome back to Numboy. Today we'll be going over integration by parts. So this video is a mainly just example video. I won't be going on over how to do it, but I will be using the method the methods you do need to solve each integration by parts integral. So let's just get straight into it. So our first question here is the integral of x sine x dx. Now the way we do this is we first assign a u to a value. I'm going to use x as my u, and you'll see why in a second, and then we have a dv value, so I'm going to assign sine x as my dv value there. Now what we do now is we have to differentiate u, so we get du equals, what's differentiation of x with respect to x? I mean, it's meant to be du of dx, but just ignore that part there. Well, that's just 1. And dv, we have to go back up, so what is that? Well, v is just minus cos x. So now we have to use the formula at the top of the page here. So we have uv, which is x minus cos x, which we can just write in brackets here. And then we do minus the integral of v du, which du is 1, so we'll just not put that in. And then v is our minus cos x, and this is with respect to x. Now this can be simplified as cos x of x, and then this minus can be brought out because it's just a constant minus 1 if you want to say, so this can be positive of the integral of cos x dx. Now if we do this integral, we'll find that we get plus sine here, and obviously we need our constant c, and we'll bring this one down again, cos x. Oh, yeah, we'll just do it with that. So this is our answer to this integral here by doing integration by parts. As you see, we worked through it, got a u, got our v's, got a dv, got a du, and then we put them all into this equation up the top here, and we got this as our answer. Right, let's move on to the next question. So this is our next question here. Now, what should we normally set as our u here? So we need something that will break down. Now if we're smart about this, we'll see that this x squared, if we differentiate it, we'll get 2x. So that's breaking down, that's getting towards a smaller number. And if I'll give you a tip here, we have to do double integration by parts here. So this one, if we had it as a u, if we integrate it, we'll just get the exact same value. So there's no point in setting that, because you just end up going on forever and forever, because you'd never actually get anywhere. So let's go this by setting u as our x squared and our dv as our x, e to the x, sorry. Now our du is 2x, because the derivative of x squared is 2x, and our v is just e to the x. Now if we use our value equation up at the top, which is best to remember it, this is actually put in post because I don't need it, because the better you remember it, it's easier to do in questions rather than trying to recall it. So we have our uv, which is our x squared ex, and then we minus the integral of our v du, which is our 2x ex to the power of x. Now as you can see, this probably have to do integration by parts again. So I'm gonna, obviously remember that you've got this part here, so I'm gonna just do a little aside down here really, and do integral of 2x ex dx. So if we set our u again to be 2x, our du will then just go to 2, as you got rid of the x value, and we set our dv to equal ex, our v will just be ex. Now if we do the integration by parts here, we'll see that we have uv, which is 2x ex, minus our integral of 2ex dx, which then can just go towards 2x ex minus 2, and then it's just the integral of ex to the power of ex, which is just ex there, plus our c. Remember, we've got this value up here, so put it all together, we get an end value of x squared ex minus, remember, minus this whole thing here, so minus 2x ex, and then we have the minus of this minus, which gives you. So yeah, that was an example of a double integration by parts here. I've set it up a bit weird. You can kind of just do it from here, like set it down again, but I've set it to the side so it's a bit easier to follow, hopefully. But yeah, you can what you can do is do it down here or do it to the side, and just make sure you carry this minus. So like this minus, because this is all in brackets here, this minus here makes you a positive here, and obviously your plus c, it doesn't really matter because it's constant. It doesn't make a change to the minus. But yeah, this is your answer to this equation up here. Let's move on to our final integration by parts question. So this is our final question here. As you see, we've got the integral of 2x e to 3x dx. Now, although this ex has got a value in front of the x, if you know what you're doing, like with integration differentiation, you'll know that whatever you do, this is not going to tend towards, like, go smaller. It's going to get smaller because of your fraction, but it's not going to get nicer per se. So I'm going to set our u to be our 2x, because then when we have our du, we just get 2, which is much nicer than if we had anything to do with this e to the 3x. And then our v equals 1 over 3 e to 3x. Now, using our formula at the top, we have 2x. And then we have v, which is 1 over 3 e 3x, minus the integral of 1 over 3 e 3x and 2 again dx. So now we can sort of make this nicer. So this 2x, this can come up here, 2 over 3 x e to 3x, much nicer to look at. And we got our minus, we can put this 2 and this 3 out front, 2 over 3 integral of e to the 3x dx. Now what we do is just take that 3, divide it by it, so then we get minus e 2 over 3 bracket 1 over 3 e to 3x plus just c, and we have to carry this one down again, x 3x. So this then just simplifies to give you a final answer of 2 over 3 x e to 3x minus 2 times 1 is 1, 2 times 1 is 2, 3 times 2 is 9, so you get 2 over 9 e to 3x plus c. So if you just use the formula, you can easily break down a question like this, break it all the way down to get a nice, well, not really nice looking, but an easier, you'll integrate it to get your value. There you go. Well, I hope this video was informative, guys, and I hope it made sense of integration by parts. Make sure you smash like and subscribe if you enjoyed, and I'll see you in the next video. Goodbye.